Hi there, I wanted to go over a couple of the problems that we skipped. The first one is in the cylindrical shells section, so section 6.2. It was under example 1, letter D. So we have here x plus y equals 4 and x equals y squared minus 4y plus a 4, and I'm rotating around the y-axis. So let's take a look at this one. Let's start out by finding common points. Since this function, well, not function, this expression, um, the one right here, this one is in terms of y, and it's so complex. I'm going to use cylindrical shells anyway, but if I was toying with which one to do, I would want to keep that one so I don't have to solve for y. Okay, so this is one of those cases where I would use a cylindrical shell because I'm rotating around the y-axis or the x-axis, and my expression is in terms of y, and I really don't want to have to solve it the other way. So let's get the second one in terms of x equals also, so it's in terms of y. I'm going to say this is equal to x equals 4 minus y. All right, now they're both in the same terms. I'm going to go ahead and find my common points. I'm going to set them equal to each other. I'm going to have a y squared minus a 4y plus a 4 is equal to 4 minus a y. If I move everything to one side, I get a y squared. My negative 4y becomes a positive. Well, a negative 4y plus a y is going to be minus 3y. And my 4's are going to cancel, so I'm going to get an equals 0 there. So it's going to simplify quite a bit. At this point, I can factor. So I'm going to take y times y minus 3 equals 0. That gives me 2 points of intersection at y equals 0 and at y equals 3. So the first thing I want to make sure is if I'm given anything like, there's a boundary at, let's say, y equals 2 or something like that, then I'm going to cross out the y equals 3. There's not one here. So I'm going to keep going. I'm going to find my points. I'm going to use the not highlighted equation. So let's highlight it in green. I'm going to use this equation to find my x's. I'm going to say that when y equals 0, x equals 4 minus 0, which is just 4. So I have a point. That's 4, 0. Be really careful when you do those y's backwards. It's really easy to write them backwards on the ordered pairs. And then when y equals 3, x equals 4 minus 3, so it's going to equal 1. So I'm going to have a point at 1, 3. Again, really careful on how we write it out. All right, let's see. So let's go ahead and try to start to graph this. I have a couple of points. I'm going to go ahead and make this little part that we just did just a little tinier, just so that it's out of our way. All right. So let's make our graph. We're going around the x-axis. I'm going to mostly focus on quadrants 1 and 2, or 1 and 4 here. So let's pull this back over this way. Let's see. I can see that I go to 4, 0. So 1, 2, 3, 4, 5. We'll go 5 this way. This is my x-axis. This is my y. And so I have a point. I'll put it in blue at 4, 0 right here. Let's zoom in. I have a second point at 1, 3. So the 1's already on there, but let's make us go up to 3. 1, 2, and 3. So again, in blue, I have a point right about here. Now I know that the x equals 4 minus y, that's a line. So I'm just going to make a straight line off of that. I didn't even connect the dot. There we go. All right, so that is our line. If you want to know which one's on top or the bottom, the easiest way to do that is to pick a point between the 1 and 3 for the x values there, or a point between, in this case, given what they look like, let's pick a y value that's between 0 and 3. And we'll go ahead and sub that into the second yellow equation. So I'm going to say down here at y equal to 2, then x is equal to 2 squared minus 4 times 2 plus a 4. So I'm going to get a 4 minus an 8 plus a 4, and that's going to equal 0. That means that I have a point at x equals 0, y equals 2. All right, so what I'm looking at is that yellow expression is a parabola, and it opens to the to your right hand side. I'll get the right direction. So I have a point here. It's actually my vertex, and so I'm going to have something that looks like this. Well, if I attach to that, imagine that's attached. I don't know why I'm in yet another color. So you get the idea. The region that I'm going to rotate here is going to be this thing. All right. So I'm going to take a look at how to rotate this. I'm going around the x-axis. So I'm going this way around. If you want to go the other way around the x-axis, you can. So I'm going to go ahead and put 3 points going down in the negative. 1, 2, 3 negative y values. Let's see, I know I'm going to have a little point right here that's kind of symmetrical. I know I'm going to have a line that goes over to my 3, 1. I know that I'm going to have something that goes, kind of looks like butterfly wings to me. All right, so that's basically what we've got there. I'm going to go ahead and draw my cylinder now that I drew my graph. Looks a little unsymmetrical, but we'll pretend. I think it should be a little bit more down, like, well, down there just a little bit more. Let me grab this. It's going to bug me. It's just a little too high. Let's fix it. All right. I'm going to go. They look better now. All right. Okay. So let's draw our cylinder. So I'm going to go right here and about the same place on the other side. I'm going to have a sideways cylinder here. So here's my cylinder. Okay. If we look at this, again, let's draw it outside of the graph a little bit for us. So here's my bottom of the cylinder. My top as I go around. If you want to do your inner part, again, I said I did this in terms so that I would do a dy integration and integration with respect to y. We can confirm that that's true there. And I did that largely because of the yellow expression, all right? If I'm looking for my radius, I'm going from this x-axis all the way up to here. That's the y distance. So I'm going to say, if I draw it on here, that r equals y. If I'm looking for my height, what I'm looking for, let me get the highlighter thing. I'm looking for the distance from here to here. So I want it to be positive. So I'm going to take this equation, whatever that expression is, minus this one that goes like this. Or if you want to think about it up here where we actually have our original solid. So let's do that. I'm going to go back to pink. I'm going to say that my height, the one that's the straight line, is the one that is the furthest over there. So let me kind of highlight. This one is my green one. And no, yeah, okay. I thought I was doing it backwards. And this one is my yellow one. So if you're trying to figure out which is which, you know now. All right. So we're going to take the green minus the yellow. So I have a height that's equal to 4 minus y. I'm going to parentheses both of them minus that whole expression of y squared minus 4y plus 4. All right. If I clean that up a little bit, because right now it's pretty long, my 4's are actually going to cancel out, because if I take the parentheses out, I get 4 minus y squared. I'm distributing plus the 4y minus a 4. So these 4's, I have a 4 minus a 4. Those are going to cancel out. I have a 4y minus a 4y, so I'm going to have a 3y minus a y squared off of that. All right, that's my height. If I want to open this thing up, let's open it up right over here. We'll open it up right next to the height. I won't have to rewrite it. I'll cheat on writing here. You guys know how much I love to write. So my height, it goes right here, right? My circumference in this particular case is going to be, circumference is like I unwrapped it from the water bottle. It's equal to 2 pi r. In this case, my r is y, so it's equal to 2 pi y. Right? So now we can find our area equation. I'm going to use, let's highlight again. Maybe we'll highlight. Okay, I'm going to use the thing highlighted in purple. That's my width or my height. And then this is going to be my other dimension. Okay, so if we do width, length times width, I've got one of each there. All right, so let's write this out. I'm going to get my area. This time it's in terms of y. All my expressions are in terms of y. Is equal to 2 pi y times a 3y minus a y squared. I really encourage you to try and clean it up before you go to the integral just because it saves your writing. So I'm going to have a 2 pi times a 3y squared minus a y cubed. And that's going to be my area. All right. Looking good. All right, let's go on and we're going to do the volume. I have a little room down there. Let's move the area over next to the area and I'll do the volume down at the bottom. All right, so that's my area. All right, so if we make a little line right across here, let's do our volume down here. Let's see, volume is equal to the integral from c to d. Remember, because I'm doing an a of y dy. That's going to be equal to the integral. Well, let's pull that 2 pi out front. 2 pi, I'm grabbing my area, the integral of my 3y squared minus y cubed dy. My integral, let's look at my lowest y value just on the shaded region. So all I'm looking at is this part up here for my y's, because remember I only want half of them. So I'm going to go from 0 all the way up to 3 because that's my biggest y. You can double check here. I go from 0 to 3. All right. So my limits of integration are going to be 0 to 3. I have my dy on the end. Everything looks good. Let's go ahead and integrate. So I get a 2 pi. I'm going to get a 3y squared divided, or y, let's try again. I'm going to get a 3y cubed divided by 3. So I'm going to get a y cubed when I reduce it, minus a y to the 4th over 4. I'm going to evaluate that from 0 to 3. So let's go ahead and sub in. My volume is equal to 2 pi. Don't lose that 2 pi. Times, subbing in my top number, I get a 3 cubed minus a 3 to the 4th over a 4 minus, if I look at my second term, both of these, if I sub in here, it's a 0, and I sub in here, it's a 0. So I'm going to go ahead and say minus a 0, just so it cues me in that I checked it. So if I do all of the math there, you should get a 2 pi times a negative, well, I have them backwards, 27 minus an 81 fourths, which is going to give you, if I had a common denominator, a 27 pi over 2. If you want to write the pi at the end, you're welcome to, or you can write 27 halves pi. Well, that takes care of that problem. Just so you have the whole thing all at once. There you are. Not too bad. It's a nice cylinder there as far as what we have going on. All right. Let me know if you have any questions, and I hope you find this helpful. All right.